Is intelligent design defensible? What about the argument from the Mousetrap and irreducible complexity? Can this still be defended today? Well, these are very important questions that relate on so many different worldviews. And we have a guest with us today. If you follow these discussions, you will recognize him. Dr. Michael Behe has written a number of books in this regard. And specifically his book, now it's been 25 years, Darwin's Black Box, really helped kick off some of the discussion about intelligent design. So, Dr. Behe, we really appreciate you coming on and being willing to answer some of the questions related to your book in the intelligent design movement.
Thanks, Sean. It's my pleasure to be with you. Looking forward to it.
So you have a new book that's just come out called A Mousetrap for Darwin. Tell us what makes this book unique and what you're trying to accomplish in it.
Yeah, it's a collection of essays I've written over the past 25 years since Darwin's Black Box first came out. And as you know, there have been a lot of objections and counter arguments. And I have addressed all of those in different venues at different times. And I thought it would be good to collect them all into one book so that it's more easy for critics to read it and see that I've actually addressed all of their objections already. And it'll be good for supporters of ID to read as well in case they have been, if they've been wondering about some points as well.
We're going to get into some of the nuts and bolts of it, but this is a 500 plus page book. And I'm not a scientist, so I would say to readers that this is not a beginning book. It's intermediate. It's very readable, but it's also going to challenge you to understand some of these issues. So whether you believe in intelligent design or reject it, if you want to be caught up on where the discussions are, I think your new book, Dr. Behe, does a great job of getting us there. Now, let me ask you a kind of controversial statement that showed up in the book, and you said this. You said the eclipse of Darwinism in the scientific community is well advanced. Explain what you mean by that, and if you still hold that view, even though you said it some time ago.
Yeah, I certainly do still stand by it. It's acknowledged by many people. I would estimate anyway about a third of even evolutionary biologists don't think that Darwin's theory is the whole story. That there are groups of people pushing other ideas, not intelligent design, but other ideas about how life might have arisen and developed. For example, some people point to something called niche theory about how organisms interact with their environment, and others talk about epigenetics. That is, there are machines in the cell which modify DNA in real time, and maybe that has something to do with evolution. Other folks say, well, the machinery that modern molecular biology uses to do experiments on DNA, much of it is actually derived from the cell itself. So if we can do experiments on DNA, maybe the cell itself can in a non-Darwinian fashion. So there's a website. It's called, I think it's called The Third Way, which is put up by very prominent biologists and philosophers and other academics, arguing explicitly that Darwin's theory has been overblown and that we have to look elsewhere for ideas. So the newspaper magazine assertions that, oh, we've got it all settled, that's incorrect.
Well, so what do you think it's going to take for the larger scientific community to recognize that Darwinism is done? If you say a third of it are questioning, what would it take for them to go, you know what, we're past this?
Well, that's a great question because it's more a question of sociology rather than of science. Because, as I said, most people already say or a lot of people already say Darwinism is on its way out. And I think probably it'll take a couple of big name biologists respected by the whole community who aren't who aren't known to be religious or such, to come out and say, Darwinian processes just can't account for this, and neither can any other process so far advanced. And I think that will have the big impact when somebody inside the community says it's time to move on. Then I think other people will join in.
That's really interesting to hear, and that makes sense. We're here, for those of you who's joining us, we're here with Dr. Michael Behe, author of, famously, Darwin's Black Box, has a recent book out called A Mousetrap for Darwin, and we're going to be debating, or not really debating, I'm going to be posing some of the challenges to him and hear him respond to some of his work. But first, I have a question for you that is more theological than it is scientific. But in this text, I'm just curious where you would go with this. You said, quote, "I agree that the Darwinian mechanism, rightly understood, is theoretically compatible with Christian theology." Can you unpack what you mean by that?
I guess. First of all, I'm not a theologian, of course, so I'm kind of winging it. I'm like the guy on the next bar stool giving you my impression about this. But if I understand, but with the Darwinian mechanism says that with random changes and natural selection, you could potentially build new things. Well, you could imagine God setting up the universe so that functional systems are so close together that a mutation here or a mutation there would snap things together and give new functional systems. And you could also imagine that he set up the universe in the knowledge that it would proceed to give us, and especially me. So if you consider that to be Darwinism, which, I'm sure you could get some arguments about, then I think that would be okay. So that's what I would think of as Darwinism rightly understood. But I don't think the scientific evidence is compatible with that.
That makes sense. For those of you watching, I'm not sure why the video is a little bit out of sync with the audio, but you're coming through clear. So we were able to track. That's no problem. Maybe it'll catch up with the internet wave here in a moment. Now, I'm curious. We're 25 years out from the release of Darwin's Black Box. What surprises you most looking back about a quarter century from the release of that book?
Well, it surprises me. Initially, when I wrote the book, I thought that my arguments would be slapped down within a couple months because some folks in the field would say, "Didn't you see that paper that was published 3 years ago in this journal, which shows how Darwin's mechanism can do this or that or the other thing?" And astoundingly, nobody did that. And the even prominent scientists, very world famous scientists, said things like, "Oh, you're not allowed to say things like that," or maybe in 25 years we'll have the answer. But it turns out we don't have the answer in 25 years. And so I guess the thing that surprises me most is that nobody seems to care. I mean, in my book, Darwin Devolves, which was published a year or so ago, I had an afterword in which I looked at the examples that I discussed in Darwin's Black Box and showed that nobody's even tried to explain how a Darwinian process could produce the blood clotting system or the flagellum and so on. And yet people go along their merry way, scientists do, and don't pay it any attention. Every now and again, the most you hear about intelligent design is some denunciation in the science literature, but nobody says, this might be true.
One of the differences within the intelligent design community is whether or not you believe in common descent. I'd be curious, a two-part question for you. Make a distinction between common descent itself and the mechanism of what drives evolutionary theory. And then second, I'd love to just hear, why is it that you believe in common descent as a whole? What convinces you that there is common descent?
Okay. First, the distinction between common descent and the mechanism. Turns out that Charles Darwin was not the first person to propose evolution in the sense that organisms today are descended from organisms in the past. A number of naturalists had proposed that before him, but they all had teleological or guided forces to account for the changes in life. One that many people might have heard of is what's his name? There was a Frenchman who proposed that, say, giraffes' necks would get longer by them striving to eat the leaves higher on trees.
Gotcha.
And so it was kind of teleological. It was nature exerting itself or some inborn guidance. Darwin's claim to fame is not evolution per se. It's that he proposed what he thought was a completely ateleological, completely mechanistic, unguided, unintelligent process to, move life along. And that was, of course, random variation, or random mutation, as we say these days, and natural selection. So the second part of your question is, why do I think common descent is true? Yes, I'm close to one of the few in the intelligent design movement who do think that. And I guess one of the big reasons is that I don't care much about common descent. Just because, as I said, the mechanism is different from the idea of common descent. And if you think about it, common descent is kind of a trivial statement. It just says that, well, there were ancestors in the past, and then they gave rise to descendants that are around us now, and maybe very different descendants. But it doesn't say where the ancestors came from. And it doesn't by itself say how in the world such fantastic transitions could happen. So in a sense, it's pretty trivial. Also, the idea of natural selection, Darwin's own idea, I also think that's trivial. It says that organisms that are more fit to their environment will tend to survive. Well, okay, great. Who's going to gainsay that? In my view, 99.99% of the philosophical, maybe even theological, and certainly scientific importance in Darwin's theory is in the idea of random variation or random mutation. That is, utterly random changes can be fed into natural selection and produce the exquisitely designed, exquisitely made organs that we see in modern organisms. And it's been my experience that that Darwinists will be happy to talk with you all day about common descent, and they run like vampires from garlic if you ask them how a random process could produce these wonderfully coherent, elegant systems we find in life, and especially in the cell. So I keep my argument focused on just that, and I am happy to grant common descent for the purposes of discussion. In my view, it doesn't really matter. And again, I'm not much of a theologian, so I don't have any strong opinion about that.
That's fair. That's really helpful. I appreciate you clarifying where you're coming from on that. By the way, those of us just joined us, we're here with Michael Behe. You probably know who he is from his writings on intelligent design. And we're talking about his recent book, A Mousetrap for Darwin. And we will be taking some questions. If they relate to the larger topic, ask your questions and we will pose them for him. Would be a lot of fun. All right, here's one statement that you make in the book. You say, viability related to the viability of non-Darwinian mechanisms. You say, while each new idea usually can explain at least one area of biology reasonably well, none seem any better than Darwinism itself in accounting for the whole. Can you explain what some of these other mechanisms are to account for this change, and why you think maybe just one or two prominent ones, and why they lack to explain the complexity and diversity of life, in particular these complex machines?
Sure. One neat mechanism is something called niche construction, spelled N-I-C-H-E. So some little corner, a niche of the biological world. And the idea there is that Darwinian theory says that organisms are shaped by adapting to their environment. But in niche construction, they point out that for many organisms, the organisms actively shape their environment. They're not passive pawns in under the control of the environment. And a swell example of that is the African termites. There are termites in Africa that can build termite mounds 30 feet high, really crazy, huge.
Wow.
And they construct them to be ventilated. They have holes to let air in and out, to regulate the temperature, the humidity, and they raise the next generation of termites, not in the environment at large, but specifically in the termite mound that they themselves created. So essentially, they are adapting the environment to themselves rather than themselves to the environment. And you know, that's a wonderful point. I think it's great, but it kind of stops there. That they don't go on to explain where termites came from in the first place. They don't say how this would cause any, say, molecular events to change. And so it's an interesting idea, and it does present a problem for Darwinism, but it does not explain how purposeful systems like the termites themselves could have come about. Another example is something called natural genetic engineering, and that has been proposed mostly by a man named James Shapiro at the University of Chicago. And he writes that, well, you know, cell biologists and biochemists, when they do experiments on systems like cells and so on, oftentimes manipulate the DNA of these organisms, clone things and other stuff by using tools, enzymes from the cell itself. Enzymes, proteins, tools that can cut DNA at specific places, that can take it and insert it into other places. And you can add pieces of DNA here and there to direct it to do some things, certainly not the cool things that the cell does, but many interesting things. And he says, well, if we can use the tools of the cell to do these experiments, why can't the cell itself use those same tools to help evolution along? And that's an interesting idea too. It's very nice, but it's pretty much intelligent design. He says that the cell is purposely putting things various places and because it wants to evolve, or because it has a plan. And so he's kind of ascribing intelligence to the cell itself. And even worse, in my view, is that he doesn't say where these tools came from in the first place. Where did the enzymes come from that can cut the DNA and clone it and replicate it and so on? So it's kind of a chicken and egg situation because it needs the tools to make changes. And if you think that Darwin's mechanism is sufficient to come up with those tools in the first place, which he doesn't dispute, then why can't it be clever enough to do everything else too? So all of these, and these are just two, there's a handful of other examples too, but all of them suffer from the same problem that Darwin's theory does. And that is that in order to get complex functional systems, you got to put this piece here and that piece there and another piece here. You have to arrange them purposefully. And nobody has been able to get purpose from an unintelligent source. So I think intelligent design theory is still the top of the heap as far as explanations for life.
So if I were to sum up what you're saying, a number of scientists are questioning the Darwinian mechanism, natural selection acting on random mutation, but have put forward a number of additional or different mechanisms to describe the process. But in your assessment, they still fail to account for the irreducible complexity nature of machines we see in biology, and they fare no better than Darwin's mechanism does. Is that a fair summary?
Yeah, it is. And I should add that we've got evidence that they don't do even as well as Darwin's mechanism. In my second book, The Edge of Evolution, I discussed the evolution of a resistance of malaria cells to a chloroquine, an anti-malarial drug. And I point out that in its journey before it evolved this resistance, there were 10 to the 20th, an astronomical number of malarial cells in the world that could have evolved or could have mutated or something to produce some really snazzy new molecular machinery. And it turns out that when the changes conferring chloroquine resistance onto the malaria were discovered, they were just two crummy little changes in a pre-existing protein in the malarial cell. So that, I think, was just straight, pretty much Darwinian microevolution. You didn't see any niche construction. You didn't see any natural genetic engineering. You didn't see the involvement of any epigenetics or anything else. So I think, I myself personally, I think Darwin's mechanism explains more than the ones that are trying to replace it.
You wrote this in the book. You said the most profound insight, which is pretty powerful to say, the most profound insight of modern science is that life is based literally on machines made of molecules. So number one, you say it's the most profound insight. Number two, literally machines made of molecules. I'm not a scientist, but one of the pushbacks that I've seen is that that's not really a fair analogy, that we're reading something into nature that's not there, that they're not actually machines. What's your take on that?
Well, they're wrong. If you've ever looked at a picture of a flagellum, a bacterial flagellum, which many people have who follow these issues, you can see it's an outboard motor. It looks like an outboard motor. It has a part that spins around, that pushes against water, and a motor that rotates it, and so on. And if you look in the dictionary, the definition of a machine is something that has an assembly of parts that uses energy to do some specific task. And that matches the flagellum and lots of other things in the cell to a T. What's more, I would say to the folks who say that's not a machine, I would say, well, are you a vitalist? what is this mysterious, substance that you think, these are made of? The flagellum and other molecular machines are made out of carbon and oxygen and hydrogen and nitrogen and phosphorus, the same carbon and oxygen that we see everywhere else. There's nothing spooky about it. Their only difference between inorganic elements and what how they are in the machine is the way they're assembled. Just like, say, for a lawnmower is just composed of steel and plastic and maybe some electrical parts. If you had a lump of steel and a glob of plastic on your lawn and you had a can of gasoline next to it, that's not going to cut your grass. You have to have it arranged correctly. And everybody admits that's a machine. Now, if you made that out of proteins, it would still be a machine. So I disagree strongly with those folks who don't think of that biological machines as real machines.
One of the objections I hear frequently is that intelligent design is not falsifiable. And I read one in the book you're responding to, kind of a critic who said if we disproved one example of design, then they would just move to another example of design. And it got me thinking, and correct me if I'm wrong on this, that for intelligent design to be true, all there has to be is one thing that's designed. But on the opposite side, everything has to be explained by natural processes. So it does seem to me if we found a way to explain the flagellum through natural processes, it wouldn't defeat intelligent design, and maybe we could move on to another example endlessly. What would be your response to that? Is that fair?
Yeah, it is, but with some caveats here. Yeah, I think C.S. Lewis was, or maybe it was G.K. Chesterton, who said that science, somebody who follows scientism can't admit one little miracle into their worldview, but a Christian can happily say that much of nature proceeds according to law, and that's the case. I would say to the person who said that, well, nonetheless, there's lots of machines around in biology. So if we, through great labor, show that this machine could be produced by Darwinian processes, you just go to another. So, you're not playing fair. And I would say, well, okay, maybe we can talk about this, when you show that any molecular machine could be produced by Darwinian processes. So far, and especially as I talk about in my book from last year, Darwin Devolves, Darwinian processes proceed mostly by degrading old machinery so that it doesn't work as well or it doesn't work at all from what it did. It does not create new stuff. And this is pretty constant over lots and lots of different situations. I would also say that if a Darwinist showed that a machine of a certain degree of complexity could be achieved by a random mutation natural selection, then I myself would assume that anything of that degree of complexity or lesser complexity could be also done by Darwinian mechanism. Not necessarily greater complexity, but lesser. If somebody showed that the flagellum could be produced by Darwinian processes, I would look pretty silly saying that, well, hemoglobin can't because it,
Gotcha.
But nonetheless, Darwinists haven't been able to show that even something called a disulfide bond could be produced by their mechanism. And a disulfide bond, as I explain in this recent book, Darwin Devolves, it's kind of like a hook and eye latch. If you take a hook and you put it into an eye, and you can kind of latch a door shut. That's kind of a basic a basic example of something that needs cooperation. One of those two elements won't do it. You need both the hook and the eye to come together. The hook by itself doesn't do it. The eye by itself doesn't do it. And it's been calculated that it would take an extremely long time just by random processes to come up with such an element. And it's kind of like Darwin is saying, kind of puffing up and saying, ha, my theory can explain an outboard motor. That's no problem. And you say, okay, well, tell me how that hook and eye latch on the shed where the motor is stored, tell me how that came about. And he says, well, you'll have to come back and talk to me later. We're still working on that. So if they can't explain kind of the flip side of my contention that I would accept anything simpler if somebody showed that something more complex could be made by Darwinian processes. The flip side is if Darwinists have trouble explaining something simple, then we can take it as given that they don't know how anything more complex than that could have arisen. And they have problems explaining even the simplest degree of cooperativity in life.
That's really helpful. I appreciate that clarification. Let me ask a question. I've followed you for 25 years, read your book. I wrote the book with Dembski a few years ago, Understand Intelligent Design. We have a chapter on irreducible complexity. And I've noticed that you've gotten criticism from, say, young Earth creationists, old Earth creationists, atheists, agnostics, pretty much everywhere as far as I can tell. And in some ways, that's a compliment that a lot of people have taken your ideas seriously. And even Alvin Plantinga, one of the greatest philosophers of our day, who I have just unbelievable respect and appreciation for, offered a criticism of some of your ideas in his book, Where the Conflict Really Lies. Would you be willing to state kind of what his criticism was and then what your response was to that?
Yes, Dr. Plantinga, whom I also admire very, very much, I've talked to a number of times and so on. He was commenting on a point made by another philosopher of science, whose name escapes me. And the other, it's Elliot Sober. Elliot Sober, a well-known philosopher of science at the University of Wisconsin. He said, well, the thing about saying something was intelligently designed is that if you look at a protein, you don't know whether or not a designer would want to make that protein. So you have to have some indication to say that, well, a designer not only is needed, but would want to make that protein. And since we have no good idea what God would or would not want to do, we can't argue for that. And Alvin Plantinga pretty much agreed with that. He says, yeah, that's right. You would have to know whether or not somebody wanted to make that. And I disagree. I mean, they are great philosophers, but I myself have never been able to see the force of that argument. So let's switch analogies and say, suppose you're on a hike and you turn a corner and you look up and you see Mount Rushmore, okay? Anybody who looked at it would say, holy moly, look, that's designed. And along the other direction comes Elliot Sober, and he says, how do you know someone would want to make Mount Rushmore? And so unless you know someone would want to make Mount Rushmore, you cannot say that it was in fact designed. And I think that's incorrect. You come to a conclusion of design based on the arrangement of a system itself, by what I've noted is the purposeful arrangement of parts. When you see parts arranged, this is put here and that's put there and that's put there, because when they're there, they can interact and do some function. That is the criterion for design. And I think Elliot Sober and Alvin Flanagan too were in the back of their minds thinking, how do we know God would want to do this? And they saying, well, we don't know if he would like to make proteins or not. But the scientific design argument is not a philosophical argument for the existence of God. It's an argument that this had to have been designed, that biomolecular machines had to have been designed. Again, it's like landing on an alien planet and finding machinery, a cool laser or something that does something wonderful, and you don't see anybody around there. And so what do you say? Gee, it's a natural phenomenon? No, you'd say, well, I guess some intelligent agent was here and made this, and he's not around anymore. We can't identify him. Additionally, I think that the Elliot Sober argument doesn't even come to grips with the idea of design. Suppose that you go around the corner and see Mount Rushmore, and you say, who would want to make that? Who would want to make Mount Rushmore? And here comes some other guy around, and he says, I did it. I made Mount Rushmore. I'm not going to tell you how I did it or anything like that, but I did it. How would you know he was telling the truth? How do you know that he, in fact, did so, especially if you don't, especially if you didn't see him doing so? How would you know that he was responsible for it? And how would you decide? I've got all sorts of thoughts going together in my head.
Sure.
But here's a key question to ask yourself. Okay, we look at Mount Rushmore, and we look at, say, Mount Everest, and most people think Mount Everest is pretty cool, but they don't ask who designed it. They look at Mount Rushmore, they immediately say, who designed that? Why do they even ask that question? What is it about Mount Rushmore that even makes them suspect that it might be designed? In the same way with a protein or the bacterial flagellum, why do we even think that it looks designed? And it's because we see these purposeful arrangements of parts. So I think the identity of the designer and its motives for making it and stuff, they might be interesting, but they are down the line from the conclusion, or at least the strong suspicion, that something was purposely designed. So,
okay. So down the line means whether we know why or who designed something. We can recognize design because of the meaningful arrangements of parts. Then it begs the question, who or what is the designer? So that's true for Mount Everest, or not Mount Rushmore, but that also would be true if we found some design that was completely different on Mars. We don't know who, we don't know why, but the arrangement of parts first could be designed, then it follows who did it. So this objection has it backwards.
That's right. And you may not be able ever to find out. For example, the statues on Easter Island. When European explorers first laid eyes on them, they immediately knew they were designed, but it took centuries to figure out who or how or when or why they were designed. So those are separate questions. And the nice thing about concluding that something was designed is that you come to that conclusion based simply on what you're looking at right now, what's the evidence right before your eyes. You don't have to dig into history or interview people to see what they think. It's the system right in front of you.
There's some great discussion going on in the kind of the chat room here. And one question was, do you believe God created the flagellum out of thin air? And I think the implication is if you haven't explained how God did it, then you can't rightly conclude that God actually is the one who designed it. So What would your response to that be?
I would disagree. I think that, first of all, I don't know how God designed the flagellum. And for myself, I stay away from the word create, because create, especially if you're thinking about it as creation ex nihilo, that's a religious term, a theological term. And I'm a biochemist. I'm trying to stick to just the physical evidence. Uh, there's no reason to think that God or a designer could not have made a flagellum over time, preparing this part here and preparing that part here, and guiding this over that way and guiding this the other way. So there's no reason that it couldn't have been a long time, even building on previously existing material. The question is, how did this coherent machine get assembled in the correct way so that it can have this function? If you here's another silly analogy, but if you went down the street and you opened a garage door because you saw that it wasn't unlocked and maybe you wanted to see what was inside, you opened it and there was a nice car, maybe a Tesla or something. And little did you know is that an hour ago, God created that car ex nihilo. Okay. You would be able to tell from looking at the car that it was designed. You know right away it was designed, but you don't know how it was designed. It could have been made in a factory. It could have been made by ordinary auto workers, and that's the way most cars get made. But this one just happened to be created. Nonetheless, you don't know that, but you do know it was intended. You do know it was designed. So the flagellum, for all I know, it could have been created in a puff of smoke, but there's no, it's not necessary to conclude design. It might have been prepared for and developed over a long period of time, but that would require guidance.
Okay. One of the works that you reference quite a bit is Richard Lenski, and just one of the eminent scientists of our day and the work that he has done with bacteria. Could you explain the work that he has done, why it's significant, and what follows from this work for naturalistic processes to produce, sophisticated machines?
Sure. Yeah. Richard Lenski is a professor of microbiology at Michigan State University. And way back 30 years ago, he undertook an experiment that has developed over time. In 1990, he decided to take a flask of nutrient broth, say essentially some water with sugar and some other chemicals in it, and he added some bacteria called E. coli, which is used commonly in laboratories. And he let the bacteria grow overnight in the flask. And there was enough sugar in it for the bacterium to go through about 7 generations, because they're so small, they reproduce quickly. And there were about 100 million bacteria in the culture, again, because they're so small. And he came in the next morning and he took a small amount of that culture that had just gone overnight, and he put it in another flask with pure or fresh culture and let it grow overnight, then another 7 generations. Then he came in the next day and did the same thing, and again and again and again for decades, for the past 30 years.
Wow.
It turns out that, yeah, he's dedicated. Yeah. It turns out that the bacteria has been growing now for about 70,000 generations. Wow. And there have been trillions of bacteria which were born and died in his laboratory. And he did it just because he wanted to see how they would change, how they would evolve. And within months after he started the experiment, he noticed that the bacteria were starting to grow faster, maybe about 20% faster than they did before. So this was due to some mutation, but he didn't know what mutation it was, because back in 1990, the technical tools did not exist to be able to track down the mutation that was allowing the bug to grow faster. And it wasn't until about, a dozen years later that the techniques to sequence DNA were becoming more common and cheaper and so on. And he discovered that mutation, the original mutation that allowed it to grow very, very fast, was due to several genes in something called the ribose operon, which holds genes for proteins that metabolize the sugar called ribose. They were destroyed. They were blown apart. They were deleted, and they didn't have that capability anymore.
Okay.
And for some reason, that made the bacteria grow faster than they otherwise would. So here was the startling notion, the startling idea people had before, but this brought it home, I think, with great force, is that a helpful mutation can be one that destroys pre-existing genetic information. And the long and the short is that 25 years after his experiment began, he tracked down about 36 different mutations that helped the bacterium grow faster or compete in its environment. And they were all ones that either destroyed or at least degraded the genes in which they occurred. And that's pretty much the big point of my book, Darwin Devolves, is that it's really easy to break a gene. Practically if you have a gene, probably 99% of the changes in it aren't going to help. Just like 99% of changes in your computer will not help. If you take a hammer and hit it here or there or the other place, it's not going to help. So, but they occur very, very fast. And ones that would happen to help it somehow, give it some new feature, well, they're comparatively rare. And just as a matter of speed, you'd expect the degradatory mutations to arrive much faster. And if by chance breaking some gene gives you an advantage, then natural selection will make that spread through the population. So the interesting thing is that now that we can track down these genes pretty closely, it turns out that Darwin's mechanism of random mutation and selection is actually powerfully devolutionary. It easily breaks genes and destroys things, and if that helps, that spreads rapidly through the population. I used this image before. If you think of a ship in a storm and it's going through and it's got a leak and you want to get to port, what's one of the things you can do to help ensure that you make it to a safe harbor? Well, you can throw overboard some heavy machinery or, computers or TV sets or tractors or whatever. And that'll help. You'll survive to live another day. But of course, you're missing your tractor and your computer and so on. So I argue at length in the book that this is really the death knell of this theory. But some people disagree.
We've got time for just a handful more questions here. If you want to load them in for Dr. Behe, we'll try to get to him in the next few minutes we have. Let me ask you one other practical example I've heard raised a lot relates to polar bears and an evolution that's taken place in polar bears. Can you explain what that is and why you don't think it challenges your ideas of ID?
Okay, well, I started out that book, Darwin Devolves, with an example of polar bears, which are thought to have descended from grizzly bears, brown bears, over the past few 100,000 years. And in these days, scientists can easily sequence the whole genomes of entire species. And it turns out that some scientists have sequenced the grizzly bear DNA and the polar bear DNA. So groups were anxious to compare the two to see what mutations had occurred that allowed the polar bear to adapt to the Arctic. And the most strongly selected gene, the one that helped the most, was one which broke a gene involved in pigmenting the polar bear's fur, so that it doesn't become pigmented like brown bear's fur, and so it's white. Okay, well, that's great, but it's a degradatory mutation. The second one is a gene involved in lipid metabolism, fat metabolism. Turns out that polar bears eat a lot of fat from seal blubber. A large chunk of their diet is that, and not so for grizzly bears. They eat berries and whatever. So one of the second most selected gene was involved in lipid metabolism. And the people who looked at this said that the mutations were very likely to degrade or destroy the action of that gene. So I use a polar bear as an example of devolution, evolution by devolution, to start off that book. Now, of course, some scientists challenged that. They said I was incorrect, and they said that, well, the prediction, or the people who published the paper on polar bears, they just used a computer program to say that these mutations were likely to damage the proteins whose genes they were in. And I said, sure, that's what I said in my book. This is a computer program that's used widely, that's reliable, and so on. And I said, you can't do many experiments with polar bears. They tend to, take umbrage. So if you use this computer program, nonetheless, proteins are easy to disturb, to break. They were predicted to damage it. And the folks essentially argue that no, you've got to show that this is damaged. And I went back and forth with these folks a couple times. And I showed that in a mouse model, mice are easier to work with than polar bears. In a mouse model, if you break that same gene, the same analogous gene that is mutated in the polar bear, then the mice become resistant to a high-fat diet. That is, they can eat a lot of fat, and they don't get the symptoms that mice with the normal gene have. It might be, you might say to yourself, how in the world can that happen? Well, think of it this way. Suppose that normally all the fat you eat and all the cholesterol too goes in through this particular portal. But in the damaged gene, the portal no longer can allow cholesterol to go in. So it doesn't go into the bloodstream in as much quantity as when the gene is functioning. And so it doesn't form plaques in your arteries and gum up your circulatory system. And where it goes when it doesn't make it into the bloodstream is unknown at this time. But if it's stopped from going there, it might stop the damage that it otherwise would cause. And apparently it doesn't cause sufficient damage going somewhere else to make it fatal. So I should say that scientists don't object to when anybody uses protein conformation prediction programs in almost any circumstance, it's only when ID proponents point out that, well, look at the implications of this. This means that it's easy to break these proteins, and that this example of a polar bear, which is held up widely as an example of evolution, it is an example of evolution, but it's evolution by degradation, not by making things new. And then you're jumped on with both feet, and things that ordinarily nobody would blink an eye for, now you have to fight tooth and nail just to get people to take it seriously.
Here's a question for you from Michael. He says, you've written 3 great books and now a 4th, which we've been talking about a little bit today, Mousetrap for Darwin. What are you looking forward to exploring and working on next?
Well, right now I'm just going around promoting the past couple of books, but I have a different topic in mind, I think, for the future. I'm not sure when. And that is a detailed discussion of the question of how do we recognize design? How do we recognize when a mind has acted? That seems, to me anyway, to be surprisingly difficult for many people to kind of grasp. They can do it sort of kind of intuitively, but easily get derailed. And so I want to write a book essentially showing or arguing for the contention that a purposeful arrangement of parts is the only way that we recognize design. And of course, we see that in abundance in biology. And so I'm just trying to get past what I thought was the easy part of the argument, that is, how do we recognize when a mind has acted?
So as simply as you can, what would be the basic distinction between that and what Dembski has argued for recognizing design with his design filter? Because he takes a philosophical, mathematical approach. What would be the most just kind of simple, without giving away where you're going in the book too much? This is the last question we'll have for you. What would be the basic distinction you would make in terms of how we recognize it? Are you going to science rather than philosophy? What would that difference be?
Well, it would be a kind of a mixture of science and philosophy, because, of course, science can't work without philosophy. Everybody has principles, right. They have logic and so on. And I hope to show that in design, the question is, we're trying to determine how a mind has acted. And science generally doesn't deal with minds. Nonetheless, when you're asking such a question, which Darwin did, Darwin ruled out the action of mind in biology without actually demonstrating the correctness of his view. So I'm going to go through simple examples and counter examples, and mostly it's certainly not going to have hardly any math, unlike Bill Dembski's stuff.
Okay.
And the thing I want to emphasize is that you don't need calculations. You don't need anything fancy. What you have to realize is that the only thing in the universe that can have a purpose is a mind. And so when we look for evidence of minds, even evidence that some person who has kind of passed out on the street has a functioning mind, is if they can act purposefully, if they can put things together, if they can put coherent sentences together. And that's the gist of it.
That sounds fascinating. When it's coming closer to coming out, let us know. We'd love to promote, help get the word out however we can. Those of you listening, Dr. Michael Behe has written his 4th book called A Mousetrap for Darwin. If you're looking for really one book that'll take you back really when you launched Darwin's Black Box to the most recent objections through 2020 and your responses to them, this 500 plus page book really captures it. So I'd say it's an intermediate text. Non-scientists can read it, but it's the kind of book you kind of got to commit to a little bit and say, I want to really understand this issue and get into the weeds. So, I wrote a book on this, but I learned a ton by working through this myself. I was like, oh, that's interesting. That's helpful. Even though I follow these debates, there were a number of insights for me as well. So really appreciate you coming on. Those of you listening, don't forget to hit the subscribe button. We have some interviews coming up. I have a medical doctor coming on to talk about the evidence for near-death experiences. We're going to talk about assisted suicide, archaeology, and the Bible. Have some very interesting, fascinating guests coming up. You will not want to miss it, so hit subscribe, notifications. And this channel is brought to you by Biola Apologetics. And we've never had you out, as far as I'm aware, Dr. Behe, but we've had your colleagues like Stephen Meyer. We've been talking with Bill Dembski about coming out, teaching a class. Paul Nelson teaches for us regularly. Maybe someday we could have you teach a class, but for those of you interested, we would love to partner with you and help train you in apologetics. And if you're not ready for a master's program, we have a certificate program below. You can get a really good discount just kind of for following this channel. So we really appreciate you joining us. And hang on, Dr. Behe, you want to say bye quickly, but thanks for those of you for asking great questions and for joining us today. It's a great live stream. Have a wonderful rest of the week.